Okay, good evening, students. Good evening, Ashi, Karan, Arohi, Rashi, Sohani, Shashwat. Good evening. So today we will be doing practice questions of states of matter. Some short answer type of questions, not very long answer type. And these appear as 1 mark, 2 mark, or even in 5 mark. There are multiple, you know, 3 or 4 parts sometimes. These questions are asked. Although the theme I have used is dark, so I hope you are able to see the question, read the question clearly. The question is, how is the mole fraction of a gaseous component related to its partial pressure and the total vapor pressure? Good. Yes, Ashi, correct answer. However, okay, good. So if you don't remember, it is actually the partial pressure is given by the mole fraction multiplied by total pressure. You need to remember all these formulas. Write down the formula if you have not done so already. Sometimes, obviously, it can be written in a different form that mole fraction will be equal to partial pressure divided by total pressure. Same thing. Don't get confused. Next question. What would be the SI unit for the quantity PV square T square by N, where they have their usual meaning? So you just need to put the units and get the value. That's the hint. So for example, pressure, you will say pressure is force divided by area, Newton per meter square. So Newton, meter inverse 2. Volume, meter cube. Temperature, K. Means here square, K square. Divided by N, that is tricky part. N is mole. So you will say mole. Uh, Arohi, you are very close, but SI unit does not contain bar. So if I consider this one, PV square T square by N, okay, I would say it is Newton per meter square pressure. Pressure is Newton per meter square. Then I would say V is meter cube. Then I would say temperature is Kelvin, so Kelvin square. Now it is meter cube whole square rather, because it is V square, so meter cube whole square divided by mole. So let's simplify it. It will be Newton meter inverse 2 meter 6, so it will be meter to the power 4, then Kelvin square, then mole inverse. That will be the answer. Yes, correct answers I'm getting. Ashi, Rashi, Vanna. Okay. Yes, Karan, you need to simplify it. So once you simplify, you will get this answer. This question is asked in 1 mark. Next question. What type of graph would you get when PV is plotted against pressure at constant temperature? So you have P and you have PV. So the graph would you get when PV is plotted against P will be like this. Okay, x-axis will be P, y-axis will be PV. How the graph will look like at constant temperature? You will get the answer if you use constant temperature. Which law is there at constant temperature? Which particular law? Yes, Shivangi, Ashi, Rashi, Arohi, Vanna, Shashwat, Mehak, yes, Ashi, Devansh. No, Devansh. Okay. So those are correct because when temperature is constant, it's Boyle's law, that is P into V is constant. That is P1 V1 equals to P2 V2 equals to P3 V3. Means the multiplication of pressure and volume will remain constant. It means it will be a straight line parallel to horizontal axis or P. So you will say we will get the graph as horizontal line which is parallel to pressure axis. Don't just say parallel line, although that is correct. It means you know it, but parallel, don't just say straight line, right? Say parallel also. Next, arrange solid, liquid, and gas in increasing order of energy. Yes, Mehak, correct. Shashwat, correct. Ashi, correct. Karan, think again. Now, increasing order of energy means all these three will have potential energy, but liquid will have greater kinetic energy. than solids. Gases will have greater kinetic energy than liquids. Means total energy, if we talk about, gases will have higher energy than liquids. Liquids will have higher energy than solids. Yes, Shashwat. Basically, it has everything. So everything is considered in potential and kinetic energy. Is divided in potential and kinetic energy. So thermal energy actually leads to kinetic energy. So when we say thermal energy, that has been considered in kinetic energy. Next question. How is the pressure of a gas related to its density at a particular temperature? This is something we have derived the formula also, and very common question. Good, Shashwat, correct. Yes, Ashi, correct. Karan, yes, that is correct. However, you need to write formula. So your answer is, I would say correct, because you say that density is proportional to pressure. But when it is that how it is related, you need to write the relationship. Yes, Tuhina, correct. Now, most of you are giving me answer as which is correct. Okay, correct. Density is equal to P multiplied by M divided by RT, where they have their usual meanings. Pressure, molar mass, temperature, gas constant, density. Okay. This D is written as rho also. So whether it is written as rho or D, it is same thing. In question, it is asked how is pressure of a gas related to its density. So you can write in terms of pressure. Okay. Then it will be D RT by M. But both answers are correct. I'm not saying that one is wrong or one is correct, because question says how is pressure of a gas related to, so we can keep pressure on the left hand side while answering such question. Next question. Why are vegetables cooked with difficulty at hill station? Just two lines answer. Yes, Devansh, correct. Just explain slightly how it causes difficulty in cooking. Arohi, yes. Shashwat, correct. However, not the temperature. Okay, only the pressure. Uh, Mehak, yes. Ashi, yes. Shivangi, yes, correct. Devansh, correct. Yes. Armina, yes, correct. Boiling point is reached, Armina. That is, the boiling point is lower. Okay, so sufficient temperature is not achieved. Boiling point is anyway achieved. Rashi, no, there is no melting point concept here, Rashi. Okay, it's only boiling point here. So what happens that at higher altitudes, so here you have sea level, for example, and here you have mountains. At mountains, you have low pressure. Because pressure is low, water starts boiling at a lower temperature. So this is the effect of pressure. You won't be saying that temperature will be low. Okay? So yes, we know that on mountains, hill stations, temperature is low, but that is not the main cause. The main cause is that the water starts boiling at a lower temperature, say at 90 degree. So now the vegetables will be cooked at 90 degrees Celsius instead of 100 degrees Celsius. So you will say that at mountains we have low pressure. This low pressure results in water boiling at a lower temperature, and hence vegetables are cooked with difficulty. What is the value of molar gas volume in liters at STP for an ideal gas? Okay, Mac, correct. So basically, it's the question is how much volume 1 mole of a gas will occupy at STP? Yes, Devansh, Ashi, correct. Whether you say 22.4 or 22.7, both answers are correct. Okay. Yes. Shashwat, Armina, Karan, Arohi, Vanna, correct. So the answer is 22.4 liters. 22.4, however, is the correct one. 22.7 should not be there, but anyway, NCRT mentions it 22.7. So that is also accepted. Next question. Dry air is heavier than wet air. Why? Just you can tell me. Obviously, I'll explain it in detail, but you can tell me in just one line. Okay, correct. However, you can just within one statement, Mac, you can explain it. Okay, Devansh, that is what Mehak says. The question is, even you need to mention, then why? Even then, why? Okay, agreed that whatever you say, fine. But how it results in dry air being heavier and wet air being lighter? Yes, Shashwat, correct. But again, you need to write one statement how it results in dry air being heavier. No, Vanna, that is not the reason, but good guess. Okay, so the answer is that wet air, obviously, it will be wet when there will be water molecules. So if we have dry air, okay, then in case of dry air, we have the, suppose we calculate the average molecular mass, okay, average molecular mass will be mainly due to nitrogen and oxygen. So whatever is the percentage of nitrogen multiplied by 28 plus whatever is percentage of oxygen multiplied by 32 divided by 100. So that will be the average molecular mass in case of dry air. But in case of wet air, average molecular mass will be, now you have nitrogen, whatever percentage, obviously it will be less, into 28 plus percentage of oxygen into 32 plus percentage of H2O into 18. Now, if you see, the molar mass of water is 18, less than both nitrogen and oxygen. So, as molecular mass of water vapor is less than nitrogen and oxygen, it will result in less average molecular mass when mixed with air. So what I was looking for, I was just looking for the last statement, what I have written. As molecular mass of water vapors is less than nitrogen and oxygen, it will result in less average molecular mass when mixed with air. The other part I have just written to explain it. Next question. Calculate the height of a column of water equivalent to 1 atmosphere. So you have water column. So suppose this is a long tube filled with water. You need to find what will be the height of the water, which will result in 1 atmospheric pressure, which will be equal to 1 atmospheric pressure. Density of mercury is given 13.6 grams per cubic centimeter. How will you find the answer of such questions? And this is something you should have studied in physics. Pressure exerted by some height in terms of density. And obviously in terms of, yes, Sashi, you got it correct. HDG or DGH, okay, in physics. The pressure of a column of a liquid is given by HDG. Yes, Arohi. Density of mercury is given because we can compare the height of mercury. Basically, what is not given, and it is expected that you should know that 1 atm is equal to 76 centimeter of mercury column. 760 mm or 76 centimeters. So height of mercury column, you know, density of mercury is given, Gg will get cancelled. So what, how to attack such problem? Understand, okay? Basically, the pressure is 1 atm. Okay? So pressure by water column is 1 atm. Okay, and 1 atm is actually 76 centimeters of mercury column. Okay, so if we compare both water and mercury, and suppose for water it is we consider it first and mercury we consider as second, so it will be H1 D1 G, and for mercury it will be H2 D2 G. Both have same 1 atm, so 1 atm by mercury, 1 atm by water. Both pressures will be equal whether it is 1 atm by water or 1 atm by mercury. So 1 atm by water will be when its height is multiplied by its density and G, and 1 atm by mercury will be its height multiplied by its density and G. Eg will get cancelled. H1 we have to find, density of water we know is 1 gram per ml. H2 we know 76 centimeters. Density is given 13.6 gram per centimeter cube. From here you will get H1. Calculate the value, 760, 76, 3s are 210, 18, 28, 33, around, it should be around 1033. Approximately. So if we have water column of 1033 centimeter, it will have same pressure as by 76 centimeter of mercury column. Both will have 1 atm pressure. Okay, one correct. 1033.6. Shivangi Ashi, correct. Okay. So exact value will be 1033.6 centimeter. So I hope you have studied this formula in physics, that pressure by any liquid column is given by HDG. In this case, pressure is same, 1 atm. So we will equate the pressure caused by mercury and water columns. So the formula we have used, pressure by a liquid column is given by H D. Okay, can you tell me what is G here? What is G here? H height, D density, we have talked about, but G got cancelled. Shashwat, Arohi, Mehak, good, correct. Karan, good, very good. Ashi, Devansh, okay. Acceleration due to gravity, good. At what temperature will both the Celsius and Fahrenheit scale read the same value? Okay, it looks Mac already knows the answer. Okay, you will, if you don't, obviously in the examination, you will have to apply the formula, okay, to write the answer. So you should know the answer. No, Rashi. Shashwat, yes, correct. Formula is correct, Shashwat. Vanna, no, rather it is opposite sign. Okay. Uh, yes, Ashi, correct. Okay. So to use the formula is that in Fahrenheit, it is given as 9 by 5 of the Celsius value plus 32. Okay. So you have to memorize this formula. A lot of students do mistake here. And one way to memorize it is slightly funny, but you can anyway memorize like that if you are facing problem that uh, फूलन ने परमचंद की बत्ती सी जोड़ दी, not तोड़ दी. Okay, so F for Phulan, Ne for 9, Param for 5, okay, in Hindi 5, C Chand की बत्ती सी 32 plus means जोड़ दी. Next question. Is Dalton's law of partial pressure valid for a mixture of SO2 and O2? You have a mixture of SO2 and O2. Will the Dalton's law of partial pressure work here? If not, obviously you have to tell me the reason. Why yes or why not in both cases? Okay. Yes, Ashi, correct. The reason is also correct. The reason is it is the answer is no, right? Because the gases must be non-reactive. Hence, the answer is no, because SO2 and O2 react to give you SO3. So instead of 2 plus 1 moles, they will combine to give you 2 moles only. So the number of moles will be different. You don't need to write number of moles will be different. That's for explanation purpose, because the reaction may result in different number of moles. You will just write the gases must be non-reactive. Next question. A manometer is connected to a gas containing bulb. The level of mercury in open arm is 2.6 centimeter lower than that in other arm of the manometer. What is the pressure of the gas if the atmospheric pressure is 752 mmHg? Normally it is 760 millimeter. Okay, 76 centimeter means 760 millimeters. Okay, but in this case it is given as 752 mmHg, so don't use the 761. Okay, so for that, if you are not getting it, this is a type of arrangement, suppose like this, similar to this is a bulb, here is some pressure, and you have some okay, mercury. So mercury is filled here. According to question, this is gas, and here you have mercury. According to question, the level of mercury in open arm is 2.6 centimeter lower than that in the other arm. So if you compare these two, this is 2.6 centimeter. So the question is, what is the pressure of the gas? If the pressure here is 752 mm of Hg. So with this explanation, you should be able to give me the answer. Now this is just simple logical question, nothing else. No chemistry here. Rather, this is physics. Anyway, you can try. Okay. However, this is very easy. Listen here. Now, as the level here is low, mercury level in open arm is low. It means atmospheric pressure is greater than the pressure in the bulb. Okay. This is bulb by 2.6 centimeter of mercury. That's why this level is low. It means the pressure is high. This pressure is high. That's why this level is low. If both pressures were equal, the levels would have been at the same level. But here it means that the atmospheric pressure, which is 752 mm, is 2.6 centimeter of Hg more. That's why it is mercury. And mercury length can be represented in terms of pressure. If it is 76 centimeter, it is equal to 1 atmospheric pressure. But here we are comparing with the length of the mercury itself. The pressure is already given in terms of length of mercury column. So the pressure in gas bulb will be less than the atmospheric pressure by 2.6 centimeter, but I will write 26 millimeter because the pressure is given in millimeter. So I'll convert 2.6 centimeter of Hg to 26 millimeter of Hg. So I'll subtract that pressure and we'll get the pressure inside the bulb. That will be the answer. What is the difference in the mercury level? The difference is 2.6 centimeter, means 26 millimeter is the difference between these two pressures. The pressure inside gas bulb and the pressure outside. But pressure outside is more because the mercury level is low there. By applying that concept, we get the pressure in the gas bulb as 726 millimeter of Hg. I hope it's clear. Any confusion you can ask. Okay, good. Next question. Why is it not possible to cool a gas to 0 Kelvin? Yes, tell me the answer quickly. Mehak correct, Arohi correct, Devansh. Uh, no, that is not the reason. However, your statement is correct. Mm, Shashwat, your statement is correct, but not the answer. Okay. Vanna, that is different question whether we can achieve 0 Kelvin or not. But the question here is why it is not possible to cool a gas to 0 Kelvin. The answer is because all gases will either liquefy or solidify before reaching the 0 Kelvin temperature. So all gases will condense before reaching 0 Kelvin. So they will not exist in the form of gas there. So that's why for gases it is not possible to reach 0 Kelvin. Next question. Name the energy which arises due to motion of atoms or molecules in a body. How is this energy affected when temperature is increased? Okay, good. Arohi, Shashwat, Mehak, Ashi. However, there is slight difference. I'll tell you, Shivangi, Karan. Okay, both are interrelated. Okay, few of you have said thermal energy, few of you have said kinetic energy, and as I have already told you, thermal energy will result in increase in kinetic energy. Okay, so it is actually thermal energy which is the measure of kinetic energy. Now the second part is, how is this energy affected when the temperature is increased? So correct answer, yes, when temperature increases, the energy increases, the thermal energy increases. Arohi, Ashi, Karan, Shashwat. Yes, correct. Good. So the answer is thermal energy. Which is a measure of kinetic energy, and thermal energy is proportional to temperature. So in the question it is asked, how is this energy affected when temperature is increased? So you will consider that specific point. You will say when temperature is increased, thermal energy will increase. Next question. Water is not used in place of mercury in barometers. Why? Water is not used in place of mercury in barometers. Barometers are the instruments to measure pressure. The answer is very simple because we have used the related formula. No, Shivangi. However, yes, you are right, but that's not the answer. Barometer, as I said, is a device to measure the pressure where you have a column, mercury column. Okay. Devansh, yes, your answer is correct. However, you have to explain a bit more. No, Shashwat, your statement is correct, but not the answer. Vanna has given me correct answer. Good. So we used the formula. Pressure is given by HDG. Now, suppose it is same pressure, 180. G is constant anyway. H and D. If density is low, G is constant. Height will be very high. And water has low density as compared to mercury. Mercury has very high density. It's actually liquid metal. So because the water, as the water has very low density, the barometer will require very long height to measure same temperature as recorded by mercury barometer. Now here in between you can write when you say as the water has very low density, the barometer will result very high, very long height. Here you can write just in between, you can write pressure is equal to HdG. After that you can say to measure the same temperature as recorded by mercury barometer. For mercury, density is high, height will be low. Next question. What would have happened to the gas pressure if the molecular collisions were not elastic? If the molecular collisions were not elastic, what would have happened? This is something very common sense answer question. Shashwat, yes. So what will be the result? Okay. Yes, lowering of the pressure, Ashi, correct. But ultimately, what will happen? Ultimately, the gas pressure would become zero. Shashwat, no, that is opposite of that. Rather, when temperature is increased, the pressure increases, not decreases. Yes, Rashi, decrease in kinetic energy. So what we will say that if the molecular collisions are not elastic, then on every collision, the particles will lose energy and would ultimately result in zero pressure. That is, all gas particles will settle down. So they will lose their energy and will settle down. Next question. Why falling liquid drops are spherical? Not related to this year, so I'm skipping this one because this is related to surface tension, which is not in syllabus. So the answer is obviously due to surface tension, which Shashwat has already responded. that is not in the syllabus. The question is, why does a liquid boil at a lower temperature at the top of a mountain than at the sea level? We have talked about it, so that's why I'm skipping this one also. Explain why water would completely fill a fine capillary tube which is open at both ends when one end is immersed in water. This one I want answer first from you. Rather, you won't be able to answer because again, this is related to surface tension. So maybe we can skip it. However, in normal sense, these questions are asked. Okay. Now the next question is, how is compressibility factor expressed in terms of molar volume of a real gas and that of the ideal gas? So this is something we have discussed, compressibility factor. So you can give me the answer. Shashwat, correct answer. Good. Shashwat, that question was related to not capillary action. Capillary action is due to surface tension. So the answer was actually based on surface tension. This one, your answer is correct. Okay, compressibility factor Z is given by V real upon V ideal. So if you don't remember, go through the notes again. Next question, explain why evaporation leads to cooling of the liquids. Basically, all these questions which are asked very frequently in your school, these are mainly, if you see, more from physics. So why evaporation leads to cooling? Yes, Shashwat, correct. Others, give me the answer. Okay, Ashi, correct. Karan, correct. Good. Okay, now to understand this one, suppose you have water. Okay, and when evaporation takes place, the liquid molecules get converted into gaseous molecules, and gaseous molecules have higher kinetic energy, and this kinetic energy is taken from the water. Hence, rest of the molecules have less energy and hence have lower temperature. You can say less kinetic energy. Because kinetic energy is transferred to the outgoing molecules. Next question, name two intermolecular forces that exist between HF molecule in liquid state, hydrogen fluoride molecule in liquid state. Two intermolecular forces. This is something when we talked about the forces, okay, dipole induced dipole, London forces, when we talked about those forces. Yes, Ashi, correct answer. Mehak, correct answer. Arohi, correct answer. Good. Vanna, correct answer. Good. So to understand HF, why specifically HF is asked. Both HCl and HF are hydrogen halides. One is hydrogen chloride, the other one is hydrogen fluoride. But if I am talking about HCl, one end will be positive, the other one end will be electronegative. So they will have, and both are dipoles. So this is in itself one dipole. The other molecule is also in itself a dipole. So there will be dipole-dipole interaction in case of HCl. But in case of HF, they are dipoles similar to HCl, but they have hydrogen bonding also, because between hydrogen and fluorine there can be hydrogen bonding. So rather they have hydrogen bonding, which is a, now this total force is a combination of the hydrogen bond as well as dipole dipole interaction. So apart from dipole dipole bond, in HF we have hydrogen bonding also. Yes, Shivangi, it is a special case of dipole dipole interaction where we have hydrogen bonding. Yes, Tuhina, correct. Good. Now, last question today. For gases like hydrogen and helium, which show only positive deviation from ideal behavior, the compressibility factor is greater than 1. Is the statement true or false? You need to remember the graph. A graph we discussed during theory class. For gases H2 and helium, which show only positive deviation from ideal behavior, the compressibility factor is greater than 1. Correct, Mehak. She correct. Because they show only positive deviation, the compressibility factor will be greater than 1. Shashwat, correct. So in case of H2 and helium, there is only positive deviation and only positive deviation. That's why compressibility factor will always be greater than 1. Other way around, if it is only negative, the compressibility factor will be less than 1. So that's what you need to remember. And that completes the questions to be done today. Take care, keep revising. Good night. Bye bye.